Hi everyone. I've had a couple questions over the same couple over the same couple problems in our practice test. So I just wanted to address those quickly in a video. So the first one is about the violins. Like everyone knows what I'm talking about probably when I say the violin problem. The key to this problem is the fact that there is one antique violin and 4 other violins. So there are 5 total violins, and only one is antique. Hence, if a person is just guessing, like someone like me who knows absolutely nothing about violins, if there were 5 of them played in front of me and one of them is antique, I would randomly guess it was the third one that is antique, and I really don't have any idea. Because there are 5 of them and one's antique, that means there's a 1 in 5 probability of me guessing it correct, or a 20%, so 0.20 or 20% chance of getting it correct. Then that means there's a 4 out of the 5 are incorrect, which is the same as 0.80 or 80%. When they want you to find your expected numbers, these expected values, if you're just, again, we're all talking about just guessing. If you're just guessing, it says how many people out of the 157 would guess correct and how many incorrectly. So it should be that about 20% of these people out of this 157 total in this case would get it correct, whatever that is. So that gives you this first value. And then incorrect would be the other 80%. That would give us this value right here. So that's how you calculate your expected number of correct and incorrect. You just figure out what the percentage is and then multiply it by the total that you've got. Then how that helps you is when you go into StatCrunch to run these tests, you need a column of expected values. So our expected values in this case are 31.4 and 125.6. And then you need a column of observed values. So in this case, we know those. They already told us those. Observed was 41 right and 116 wrong. Then you can enter those into StatCrunch, and that's what you need to run that goodness of fit test. So they don't tell you specifically here it's a goodness of fit test, but that is in fact what we are calculating here. It's a goodness of fit. So you can go in there, run that now, and that'll give you this chi-squared value. There is another question that has been asked, which is very, very similar. So I'm going to go to where I can mark on this one. This one also, you have to figure out sort of what those expected values are as far as running this. So if your coin is not biased, that's what we would assume. Our null would be we assume that we have just a regular coin, because again, that would be the boring, basic stance there, is that it's just a regular coin. The probability of flipping a heads in that case, we're talking about flipping a heads specifically, would be 0.5 or 50%. And if the coin is biased in any way, if it's weighted on one side or the other, then the probability of flipping a coin would be not 50%. It would be something else. So what we need again here is we need a column of observed values and a column of expected values. And they give us the observed ones again. So we know that 21 heads were observed and 29 tails were observed. But what should have been expected? If they flip it 50 times, or spin it, or whatever they're doing, so they're spinning it. If they spin it 50 times, and we're assuming it's not biased, then it should have been 50-50 heads and tails. So it should have been 25 heads and 25 tails. So I can sort of just reason that one out. Now I've got my expected and my observed, and now I can go in and run that goodness of fit test again. And this one actually says goodness of fit. So anytime you're comparing what did I expect with what I observed, that's always a goodness of fit test.